Kassel, Germany, November 12, 1943. Hauptingenieur Friedrich Voss stood in the technical assessment bay of the Henschel and Zone factory, a captured American transmission cradled on the workbench before him like a patient awaiting autopsy. The component had been extracted from a Sherman tank destroyed in Sicily 4 months earlier, shipped across the Mediterranean and half of Europe so that Germany's finest automotive minds could dissect it, understand it, and, inevitably, dismiss it. Voss circled the transmission slowly, his engineer's eye cataloging every detail. He had spent 11 years designing gearboxes for German armor, had contributed to the transmission systems of the Panzer III and IV, and was now part of the team refining the revolutionary new Panther. He knew transmissions the way a surgeon knows anatomy. What he saw disappointed him. "Adequate," he murmured, running a finger along a gear housing. "Adequate for a tractor, perhaps." His assistant, Engineer Horst Brenner, looked up from his notebook. "Your assessment, Herr Hauptingenieur?" Voss removed his glasses and cleaned them with a handkerchief, a habit when delivering verdicts. "The Americans have built a transmission for farmers, not soldiers. Look at these tolerances, this slop in the synchronizers. A Maybach engineer would be dismissed for such imprecision." He tapped the housing with his knuckle, producing a dull ring. "Cast steel. We use forged components in the ZFAK 7-200. The metallurgy alone." He shook his head. "This is what happens when automobile manufacturers play at war." Brenner dutifully recorded the assessment. American transmission, crude manufacture, loose tolerances, inferior materials, no innovations of note. Confirms industrial capacity prioritized over engineering excellence. Voss signed the evaluation that afternoon. In his final remarks, he wrote a sentence that would haunt German armored doctrine for the rest of the war. The American approach to tank transmission design reflects a fundamental unseriousness about mechanized warfare. Their vehicles are built to be replaced, not perfected. This philosophy will not survive contact with German engineering. He dated the document, filed it with the Waffenamt Technical Bureau, and returned to his real work, solving the persistent overheating problems in the Panthers AK 7-200 transmission. The issues were minor, he assured himself. Teething troubles, nothing more. What Friedrich Voss did not know, what no German engineer in that confident autumn of 1943 could have imagined, was that the crude transmission on his workbench would outlast, outperform, and ultimately outfight every sophisticated gearbox German industry could produce. He did not know that within 18 months the fields of France would become a graveyard for Panthers immobilized not by enemy fire, but by their own transmissions. He did not know that American tank crews would drive their Shermans 2,500 kilometers across Europe on the same components German tanks destroyed every 150. He did not know that the philosophy he mocked, build to be replaced, not perfected, would bury the Third Reich under an avalanche of machines that simply would not stop moving. But he would learn, they all would, to understand why German engineers viewed American tank design with such contempt. One must first understand what the transmission represented in German armored philosophy, and why, by late 1943, that philosophy had become an article of faith bordering on religion. Germany had invented modern tank warfare. The blitzkrieg that shattered Poland in weeks, that humiliated France in 6, that drove to the gates of Moscow in 5 months. All of it rested on a simple proposition. The tank was the decisive weapon of modern war, and the nation that built the finest tanks would rule the battlefield. Not the most tanks, the finest tanks. This was not arrogance. It was calculated doctrine born from necessity. German strategists understood their predicament with brutal clarity. The Reich could not outproduce its enemies. The combined industrial capacity of America, Britain, and the Soviet Union dwarfed anything Germany could marshal. In a war of pure numbers, Germany would be buried. Therefore, Germany would not fight a war of numbers. It would fight a war of quality. Each German tank worth 3, 5, 10 of the enemies. Superior optics, superior guns, superior armor, superior engineering in every component. The transmission sat at the heart of this philosophy. General Major Heinz Guderian, the father of German armored doctrine, had written in Achtung, Panzer, that mobility was the tank's soul. A tank that could not move was not a tank. It was a pillbox, a target, a coffin, and the transmission was what translated the engine's power into movement. It was the mechanism that allowed a 40-ton machine to pivot, accelerate, climb, and retreat. A superior transmission meant superior mobility. Superior mobility meant tactical dominance. By 1943, German transmission engineering had reached what its designers considered the pinnacle of the art. The ZF Friedrichshafen AK-7 200 transmission fitted to the new Panther tank was a masterwork of precision manufacturing, 7 forward speeds, synchronized shifting, helical-cut gears that meshed with watchmaker accuracy. It represented everything German engineering valued. Oberstleutnant Ernst von Brauchitsch, an armored warfare instructor at the Panzertruppenschule in Wunsdorf, lectured his students that autumn. The American builds his transmission to function. The German builds his transmission to perform. This is the difference between a tool and an instrument, between a worker and an artist. The confidence was not without evidence. German tanks had dominated every battlefield they'd entered. The Panzer IV had crushed Soviet armor in 1941. The Tiger, introduced in 1942, had achieved kill ratios that seemed to validate every assumption. At Leningrad, a single Tiger commanded by Hauptmann Otto Carius destroyed more than 150 enemy tanks over 18 months. When reports filtered back describing the American Sherman, German tank commanders reacted with something close to pity. Oberst Hermann Balck, one of Germany's most decorated panzer commanders, reviewed intelligence summaries on American armor in September 1943 and dictated his assessment to his adjutant. The Sherman is a peacetime tank designed by a peacetime nation. It burns too easily. It is undergunned, and its automotive components are built to commercial tolerances rather than military specifications. Against the Panther, it will be slaughtered. Against the Tiger, it will be annihilated. The Americans will learn what the Russians learned, that numbers cannot compensate for engineering. The mathematics, as the Germans calculated them, were irrefutable. The Panther's 75mm KWK-42 could penetrate the Sherman's armor at 2,000 meters. The Sherman's 75mm M3 could not penetrate the Panther's frontal armor at any range. The Panther was faster, better protected, more powerfully armed. On paper, it was superior in every metric that mattered. What the mathematics did not account for, what German doctrine had no formula to measure, was what happened when the Panther's exquisite transmission shattered after 150 kilometers of operation, while the Sherman's crude gearbox kept turning after 2,500. The Germans had built a weapon of war. The Americans had built a machine that would not stop. And in the grinding, relentless arithmetic of industrial warfare, the machine that moved would bury the weapon that broke. The transmission that Friedrich Voss dismissed as adequate for a tractor was born not in a military arsenal, but in the offices of the Detroit Gear and Machine Company in the summer of 1940, from the mind of an engineer who had never designed a weapon in his life. Oliver K. Kelly was 43 years old, a veteran of General Motors' Hydra-Matic division, and he had spent 2 decades solving a single problem: how to make transmissions that American drivers, farmers, salesmen, housewives, teenagers could operate without destroying. Not transmissions for professionals, transmissions for everyone. Transmissions that forgave mistakes, absorbed abuse, and kept working when maintenance schedules were ignored and operating manuals went unread. When the U.S. Army Ordnance Department issued specifications for a new medium tank transmission in June 1940, Kelly saw the requirements through the lens of his experience. The Army wanted a gearbox that could handle 400 horsepower, survive cross-country operations, and be maintained by conscript mechanics with minimal training. They expected something utilitarian. What Kelly delivered was a philosophy. "I told my team we weren't building a transmission for the Army," Kelly later wrote in his unpublished memoir, Gears of War. "We were building a transmission for a 19-year-old kid from Nebraska who'd never driven anything more complicated than his father's Ford pickup. That kid was going to be scared, exhausted, and operating in conditions we couldn't imagine. Our job was to make sure the transmission was the one thing he didn't have to worry about." The result was the Synchromesh Transmission Model 3, later standardized as the component fitted to the M4 Sherman. Its specifications, read against German counterparts, seemed almost embarrassingly modest. 5 forward speeds to the Panthers 7, wider tolerances in the gear meshings, cast steel housings instead of forged, synchronizers designed with deliberate looseness, what Voss would later call slop. But every apparent compromise served a purpose. The wider tolerances meant the transmission could operate even when contaminated with sand, dust, or metal shavings, the inevitable detritus of combat. German transmissions, machined to microscopic precision, seized when foreign particles infiltrated their workings. American transmissions ground the particles down and kept turning. The cast steel housings were easier to manufacture and, critically, easier to repair. A cracked German transmission housing required factory replacement. An American housing could be welded in the field by any mechanic with a torch. The sloppy synchronizers allowed the transmission to be shifted under load during movement by drivers who had received 8 weeks of training instead of 8 months. German tank drivers underwent extensive instruction in the precise art of double clutching and rev matching required by their sophisticated gearboxes. American drivers learned to slam the lever and trust the machine. Captain Edward J. Gruber, an ordnance officer who oversaw transmission testing at Aberdeen Proving Ground, summarized the design philosophy in a 1942 evaluation report. The German transmission is built for the perfect driver in perfect conditions. The American transmission is built for the average driver in terrible conditions. War is fought by average men in terrible conditions. Production began in September 1941 at 3 facilities simultaneously: Detroit Gear, Ford's River Rouge plant, and the Buick division in Flint. The manufacturing process itself reflected American industrial philosophy, where German transmissions required specialist machinists working to exacting tolerances. American transmissions were designed for assembly line production by workers trained in weeks. Interchangeable parts meant that a gear cut in Detroit would mesh perfectly with a housing cast in Flint and a synchronizer assembled in River Rouge. By December 1941, when Japan attacked Pearl Harbor, production had reached 450 units per month. By December 1943, when Friedrich Voss signed his dismissive assessment, American factories were producing 2,200 Sherman transmissions every month. By D-Day, the number would exceed 4,000. The Germans, in the same period, managed to produce fewer than 400 Panther transmissions monthly, each one a handcrafted marvel requiring 1,200 man-hours of skilled labor. One philosophy built masterpieces, one at a time. The other built an avalanche. The avalanche, however, did not begin as a torrent. It began as a trickle of burning machines in the North African desert, and for a time it seemed the Germans might be right after all. Operation Torch, the Allied invasion of French North Africa in November 1942, marked the Shermans' combat debut against German armor. The results were not encouraging. At Kasserine Pass in February 1943, Rommel's Afrika Korps shattered the American Second Corps, destroying 183 tanks in 3 days of fighting. Shermans burned in the Tunisian valleys, their crews discovering that the tank they'd been promised would match German armor was outgunned, under-armored, and, in those early months, plagued by mechanical failures that had nothing to do with enemy action. Transmissions failed in the heat. Sand infiltrated gearboxes despite the filters. Synchronizers wore out faster than expected. The 2nd Armored Division reported that 23% of its Shermans were deadlined for transmission repairs during the first month of operations. Private First Class Raymond Cooley, a driver with the 1st Armored Division, wrote home in March 1943. They told us this tank was reliable. Yesterday, I watched 3 Shermans from Baker Company break down before they even reached the line. The Krauts didn't have to shoot them. They just waited for them to stop moving. German intelligence seized on these reports with satisfaction. Hauptmann Klaus Berger, an intelligence officer with the 10th Panzer Division, compiled an assessment in April 1943 that circulated through Wehrmacht armored commands. American tank reliability is a propaganda fiction. Their vehicles suffer chronic transmission failures in desert conditions. The vaunted American industrial capacity produces quantity at the expense of durability. Our crews report finding abandoned Shermans with no battle damage, simply broken down and left behind. This is not an army that understands armored warfare. The British, fighting alongside the Americans, were equally unimpressed. Major Geoffrey Ninnis of the Royal Tank Regiment wrote in a letter intercepted by German intelligence, "The Sherman is a decent enough vehicle for training purposes, but one wonders if the Americans understand that war is not conducted on paved roads. Their transmissions seem designed for the Nevada highway, not the Tunisian Jebel." The mockery reached its zenith that spring. German tankers began referring to the Sherman as the Ronson, after the cigarette lighter, whose advertising slogan promised it lights every time. The name was a death sentence in steel. Shermans caught fire with horrifying regularity when penetrated, their ammunition and fuel igniting in catastrophic blazes that left crews no time to escape. But the nickname also carried a secondary meaning among German maintenance crews. The Sherman's transmission lights up the repair logs every time. Lieutenant Heinrich Sommer, a Panther platoon commander who would later fight in Normandy, wrote to his wife in May 1943, "We captured an American tank driver yesterday. Poor fellow was almost grateful to be taken prisoner. Said his transmission had failed for the third time in 2 weeks, and he was exhausted from the repairs. I almost felt sorry for him. The Americans have built a tank for people who have never seen a tank. When they meet our Panthers, they will understand what German engineering means." What Sommer did not know, what none of the confident German assessments accounted for, was that the failures in Tunisia were not evidence of flawed design. They were the birth pains of a learning organism. The U.S. Army Ordnance Department did something the German military-industrial system could not. It listened, adapted, and fixed. Reports from the front flowed back to Detroit. Engineers from Detroit Gear flew to North Africa to examine failed transmissions in the field. By June 1943, 17 modifications had been implemented in production. Improved seals, hardened synchronizers, redesigned oil channels for better cooling. Transmissions produced in July 1943 were measurably superior to those produced in January. The Germans, by contrast, were discovering that the Panther's exquisite AK-7-200 transmission could not be easily modified. Its tight tolerances left no room for field improvements. Its precision manufacturing meant that changes required retooling entire factory lines. When problems emerged, and they emerged constantly, the solutions took months to implement. The trickle of broken Shermans in Tunisia was becoming a stream of improved machines in Sicily. And the stream was about to become a flood. Normandy, France, July 27, 1944. Staff Sergeant Thomas Red Brennan had been driving Shermans for 19 months. He'd survived Tunisia, Sicily, and the hell of Omaha Beach. But nothing in his experience had prepared him for what happened on the road outside St. Lo on the 4th day of Operation Cobra. His tank, a M4A3 named Missouri Mule by its crew, was the lead vehicle in a column from the 3rd Armored Division's Combat Command A, pushing south through the gap blasted open by 1,500 heavy bombers the day before. The hedgerow country had given way to open farmland, and Brennan had the throttle wide open, the Continental R975 engine screaming at 2,400 RPM, the transmission shifting smoothly through its gears as the 33-ton machine surged forward at nearly 30 miles per hour. They spotted the Panther at 600 meters, a Panzerkampfwagen 5 from the 2nd SS Panzer Division Das Reich, positioned hull down behind a stone wall, its long 75mm gun already traversing toward them. "Gunner, target, 11 o'clock, Brennan heard his commander, Lieutenant Paul Whitfield, shout through the intercom, but they all knew the mathematics. At this range, the Panther would penetrate their armor easily. Their 75mm had almost no chance of penetrating the Panther's glacis plate. The only hope was speed and angle. Present the hardest target, close the distance, get a side shot. Brennan did what 19 months of combat had taught him. He didn't stop. He didn't slow down. He slammed the transmission into 4th gear and aimed the Missouri Mule directly at the stone wall 50 meters to the left of the Panther, seeking any angle, any cover, any chance. The Panther fired. The round screamed past, close enough that Brennan felt the shockwave through the hull. The German gunner was already reloading. They had perhaps 8 seconds. Brennan pushed the Sherman harder. 32 miles per hour. 34. The transmission whined but held. The tank hit a drainage ditch at speed, went momentarily airborne, slammed down hard enough to rattle every tooth in Brennan's skull, and kept moving. The Panthers' turret was tracking them, the gun almost aligned for a second shot, when the German tank suddenly lurched, stopped. A cloud of smoke erupted from its engine deck, not the black smoke of a fire, but the gray-white smoke of mechanical catastrophe. Brennan saw the Panthers' driver hatch fly open. A figure in black scrambled out, waving frantically at the turret crew. The tank wasn't burning. It wasn't hit. Its transmission had failed. Lieutenant Whitfield's voice came over the intercom, eerily calm. "Gunner, stop. Target stationary. Take your time." The Missouri Mule's 75mm spoke once. The round struck the Panther's side armor at 200 meters, penetrating cleanly. The German tank shuddered and began to burn. That night, Technical Sergeant William Dvorak, the company's maintenance chief, inspected the Missouri Mule. The drainage ditch impact had bent a road wheel arm and cracked a track link. The engine mounts were stressed. The hull had a fracture near the driver's compartment. The transmission was perfect. Dvorak documented the inspection in his maintenance log. Vehicle 3 A147 sustained severe impact damage during combat operations. Suspension damaged, track damaged, hull cracked, transmission, no faults detected, oil clean, gears nominal, synchros operational, recommend continued service after suspension repair. He added a note that would never appear in any official report. This transmission has now survived 1,847 miles of combat operations, including 2 beach landings, 14 river crossings, and 1 jump that should have killed everyone inside. I don't know what those boys in Detroit put in this gearbox, but I want to shake their hands. 3 kilometers away, Unteroffizier Marcus Reinhardt, a driver with the 2nd SS Panzer Division, sat against a hedgerow with his head in his hands. The Panther he'd driven for 6 weeks, the finest tank in the world, he'd been told, sat burning in a French field because its transmission had seized at the worst possible moment. It was the 3rd Panther he'd lost to mechanical failure in 2 months. The final drive, he told his commander, Obersturmführer Victor Braun, his voice hollow. I felt it slipping for the past 2 days. I reported it. They said there were no spare parts. Braun said nothing. There was nothing to say. Across the bocage, they could hear the sound of American tank engines, dozens of them, scores of them, advancing south, moving, always moving. What happened in the weeks following Operation Cobra was not a battle. It was a mechanical reckoning. The German army in Normandy had approximately 2,300 tanks and assault guns at the beginning of July 1944. By August 21st, when the Falaise pocket finally closed, fewer than 100 German armored vehicles escaped across the Seine. Allied air power and artillery accounted for many. American and British tank guns destroyed hundreds more. But the silent killer, the one German commanders could neither fight nor explain, was the catastrophic failure rate of their own machines. Panther transmissions disintegrated at an almost predictable rate. The AK-7-200, designed for 1,500 kilometers of operation before requiring overhaul, rarely lasted 150 in combat conditions. The final drives, the mechanisms that transferred power from the transmission to the tracks, were failing at 3 times the expected rate. Tanks that survived American fire died on French roads, their crews forced to destroy machines worth 117,000 Reichsmarks because a component worth 200 had cracked. Oberstleutnant Gerhard Tebe, a staff officer with Exelven Panzer Corps, documented the collapse in a report dated August 4, 1944. Of the 58 Panthers assigned to 2nd Panzer Division at the start of operations, 31 have been lost to mechanical failure without enemy contact. Transmission failures account for 19 of these losses. We are destroying our own tanks faster than the Americans are. The contrast with American operations was devastating. The 3rd Armored Division advanced 100 miles in the first week of August, an average of more than 14 miles per day, through enemy territory, under constant threat of ambush and counterattack. Their Shermans didn't stop for maintenance halts. They didn't wait for transmission repairs. They moved. When breakdowns occurred, they were fixed in hours, not days. The U.S. Army had positioned maintenance battalions with pre-stocked spare parts every 20 miles along the axis of advance. A Sherman with a damaged transmission could receive a complete replacement unit in 4 hours. The old transmission would be sent to a rear area depot, rebuilt by specialists, and returned to the supply chain within a week. The Germans had no such system. A Panther transmission required factory-level facilities to repair. There were no replacement units stockpiled in France. Every transmission was needed for new production. When a Panther's gearbox failed, the tank was either abandoned or cannibalized for parts. Feldwebel Otto Henning, a tank commander with the 116th Panzer Division, recorded his unit's disintegration in a diary that was captured at the end of the war. August 7th. Started the day with 4 Panthers, ended with 2. Krause's transmission failed outside Mortagne. We had to set it on fire. 11 months training to become a Panther commander. 4 weeks in France. Now I am walking. August 9th. Watched an American column pass our position. Counted 147 tanks in 1 hour. All moving. None stopped. None broken down. How is this possible? August 12th. Traded my pistol to a French farmer for a bicycle. There are no more tanks to command. The Americans, meanwhile, were discovering just how much their crude transmissions could endure. Captain James K. Morrison, commanding a tank company in the 4th Armored Division, submitted an after-action report in late August that read like a mechanical miracle. Company has advanced 387 miles in 18 days. Original complement of 17 tanks reduced to 11 through combat action. 0 tanks lost to mechanical failure. Transmission maintenance limited to oil changes conducted during refueling stops. Recommend commendation for Detroit Gear Company. The ultimate demonstration came during the dash across France in late August. The 4th Armored Division covered 60 miles in a single day. A rate of advance that would have been suicidal for German armor. Panthers could not travel 60 miles without scheduled maintenance breaks. Tigers required transmission inspections every 40 kilometers. The Sherman asked only for fuel. General Lieutenant Fritz Bayerlein, commanding the Panzer-Lehr Division, watched the American flood from his headquarters and reached a conclusion that would have been unthinkable 6 months earlier. In a message to Army Group B headquarters dated August 18, 1944, he wrote, "The American tank is inferior to our own in armor and armament. It is not inferior in the quality that matters most. It moves. Our tanks are monuments. Theirs are machines. We are being defeated by machines." The psychological transformation among German tank crews was complete. They no longer feared the Sherman's gun. They had always known it was inadequate. They feared its presence, its relentlessness. The knowledge that for every Sherman they killed, 5 more would appear, and those 5 would never stop, never break down, never give German crews the respite they desperately needed. Gefreiter Wilhelm Kruger, a loader in a Panzer IV company that had been reduced from 14 tanks to 3 in 2 weeks, told his interrogators after his capture near Chartres, "You could destroy them. We did destroy them, but they were like ants. You step on one and 10 more come, and they never stopped moving. Our tanks stopped. Yours did not. That is why you won." The numbers, compiled after the war, confirmed what German crews had experienced in the hedgerows and fields of France. The M4 Sherman transmission had a mean distance between failures of 2,500 kilometers in combat conditions. The Panther's AK 7-200 averaged 150 kilometers, less than 1/16th the reliability. For every mile a Panther could travel before mechanical failure, a Sherman could travel 16. American factories produced 49,234 Sherman tanks during the war. Of these, fewer than 7,000 were lost to all causes, combat, accidents, and mechanical failure combined. German factories produced 6,000 Panthers. Approximately 4,200 were lost, and German records indicate that nearly half of these losses were due to mechanical failure or abandonment after breakdown. The disparity in transmission production alone told the story. American factories manufactured more than 120,000 Sherman transmissions during the war, enough to equip every tank twice over, with a complete supply chain of spares extending from Detroit to the front lines. Germany produced fewer than 8,000 Panther transmissions, and every single one was needed for new vehicles. There was no surplus. There were no spares. When American forces overran the Henschel factory in Kassel in April 1945, the same facility where Friedrich Voss had dismissed the Sherman transmission 18 months earlier, they found the production floor littered with half-completed Panthers. Transmissions sat in crates, waiting for final assembly that would never come. In the engineering offices, interrogators discovered assessment files that documented German awareness of their own catastrophic reliability problems. One report, dated February 1945 and signed by a senior engineer named Dietrich Hoffmann, contained a remarkable admission. The American transmission philosophy, which we once dismissed as primitive, has proven superior under combat conditions. Their acceptance of wider tolerances and simpler manufacture has produced a component that functions reliably in environments that destroy our precision-engineered systems. We built transmissions for laboratories. They built transmissions for war. The interrogations of captured German officers provided even starker testimony. General Major Gerhard Franz, who had commanded armored forces in Normandy, told his American interrogators, "We knew our tanks were better. Every officer knew this. The Tiger, the Panther, magnificent machines. But a tank that cannot move is not a tank. Your Shermans moved. Ours did not. You did not defeat our tanks. You drove past them while they sat broken on the roadside." Hauptmann Werner Körner, a company commander in the 9th Panzer Division, was more blunt. "I lost more tanks to transmission failure than to your guns. My men became experts at destroying our own vehicles. We could not leave them for you to capture. By the end, we joked that the fastest way to kill a Panther was to drive it 200 kilometers. The Americans didn't need to shoot us. They needed only to make us move." Perhaps the most poignant admission came from Friedrich Voss himself. The engineer who had signed the dismissive 1943 assessment was captured at Kassel and interrogated by U.S. Army technical intelligence officers in May 1945. The interrogation transcript, declassified in 1972, recorded his final evaluation of the transmission he had once called adequate for a tractor. "I was wrong," Voss said. "We were all wrong. We believed that precision was strength, that sophistication was superiority. The Americans understood something we did not. In war, the machine that works is better than the machine that is perfect. Their transmission was not beautiful. It was not elegant. It did not represent the highest achievement of the engineering art. But it worked. It worked in the mud of Normandy and the snow of the Ardennes and the dust of Bavaria. It worked when our transmissions cracked and seized and burned. I have spent 30 years as an engineer, and I tell you now, the Sherman transmission was the finest gearbox of the war, not because it was the best designed, because it was the best understood. In the archives of the Bundesarchiv Militärarchiv in Freiburg, there exists a slim folder containing the personal effects of Oberleutnant Hans-Joachim Detmer, a Panther commander who died near Bastogne in December 1944. Among his possessions was a letter, never sent, addressed to his younger brother, who was training to become a tank driver. The letter, dated December 18, 1944, contained advice that would have been unthinkable from a German officer 1 year earlier. "Dear Conrad, they will tell you that German tanks are the finest in the world. They will show you the specifications, the armor thickness, the gun penetration tables. They will tell you that one Panther is worth 5 Shermans. Believe none of it. I have seen our Panthers die on frozen roads while American tanks drove past us, their engines running, their crews warm, their machines whole. The Americans have not built a better tank. They have built a tank that moves. In this war, that is enough. That is everything. I pray you never learn this lesson as I have learned it." Detmer was killed 4 days later. His Panther had thrown a track on an icy road near Neuville. While the crew worked to repair it, American tanks from the 10th Armored Division appeared on the ridge above them. The Panther's crew managed to remount and traverse the turret before the transmission, stressed beyond its limits by the cold and the track repair, seized completely. The tank that killed them was an M4A3 Sherman. It had been in continuous operation for 11 days, had traveled 234 miles through the Ardennes, and had not required a single mechanical repair. Friedrich Voss returned to engineering after the war. He worked for Daimler-Benz until 1967, designing transmissions for commercial trucks. In a 1961 interview with an automotive trade journal, he was asked about his wartime service. His response was brief. "I learned that there are 2 kinds of engineers, those who build for perfection and those who build for purpose. The Americans were the second kind. In peacetime, the first kind writes history. In wartime, the second kind makes it." The Sherman transmission never received a medal, a monument, or a parade. No Hollywood film celebrated its gear ratios or synchronized shifting. It was never beautiful, never elegant, never the subject of admiration by those who worshipped the sleek menace of the tiger or the lethal grace of the panther. It simply worked. In the mud of Italy and the hedgerows of France, in the frozen forests of the Ardennes and the shattered streets of German cities, it worked. When German transmissions cracked under stress, American transmissions kept turning. When Panthers sat immobilized on roadsides, Shermans rolled past them toward Berlin. When the mathematics of war demanded not the finest machine but the most relentless one, the transmission that Friedrich Voss called adequate for a tractor proved adequate for victory. The Germans built tanks for engineers to admire. The Americans built tanks for soldiers to drive. And in the end, that made all the difference.